Well, good morning. I hope you had a chance to do the bell ringer and that you were able to see the pattern that resulted. This kind of leads us into what we're going to be doing today. Today we are doing properties of zero and negative exponents. So the first thing we'll talk about are the zero exponent rule. Any value that is raised to the zero power always equals what? You're right. Always equals 1. Any value raised to the zero power always equals 1. So we should be able to fly through the answers for 1, 2, and 3. All of them are 1. All right, now let's look at 4. Because the parentheses means that everything gets this 0 power, we multiply 2 times 0, that's going to be 0, and b to the 0 is 0. So again, all of this equals 1. Even if you want to look at it as 1 times 1, we still get 1. Okay? Now be very careful with number 5. 3 is not being raised to a power. So that means that 3 stays 3, and what happens to y to the 0 power? Right, it becomes 1, and 3 times 1 is 3. Here's number 6. We should also be a little careful of. This negative sign is not being raised to a power, just the 14. So this is kind of like negative 14 to the 0, and 14 to the 0 is equal to 1. So that's going to give us a negative 1. And if you want to verify any of these, you can go ahead and use your calculators to verify, because the calculator is familiar with the zero property rule. I hope we're good on that part. Now let's talk about the negative exponent rule. A problem with a negative exponent is not fully simplified. In order to simplify it completely, move the factor to the bottom, and we're talking about only the factor that was raised to a power. If the factor was not raised to a power, then it doesn't move. So move that factor to the bottom level of the fraction and make the exponent positive. So basically, we don't like negative exponents, and in order to work with them, they must be positive. So when your problems are completely simplified, if you started with a negative exponent, you will end with only positive exponents. All right, let's turn our papers over. Okay, let's look at the following examples to evaluate. So the rule says we don't want negative exponents. We must make it positive, so move it to the bottom of the fraction. Well, here you don't see a fraction, so you're going to make 1. You're going to put a 1 at the top. You're going to move the 4 to the bottom, and you're going to make the negative 2 exponent a positive 2. So now you have 1 over 4 squared. Let's go ahead and evaluate 4 squared, which is what? So now we'll have 1 over 16. Okay, I want to give you a chance to do the next one. Great, you should have gotten 1 over a to the 5th. Okay, let's look at number 9. Now notice x cubed is positive. So when you see things in this form, it's almost like it's already in the denominator, okay? So our x cubed stays in the denominator at the top. Because y is raised to a negative exponent, we move the y to the bottom and we make the negative 4 a positive 4. So this is the completed answer for x cubed y to the negative 4th. Okay, let's go to number 10. Okay, so take a look here. Let's first evaluate or analyze which factors are negative and will move and which factors are positive and will not move. So 3 is raised to a negative power, so it's going to move to the bottom. R is raised to a positive power. When you don't see a power, it's raised to the first. You don't have to show that. So R stays at the top. S is raised to a negative power, so S will move to the bottom and the 2 will become positive. Now let's go ahead and evaluate 3 to the 4th. And that's going to give us 81. So our final answer will be R over 81S squared. How are we doing so far? Good. Okay, let's go to number 11. Remember, let's take a look at what's going to move and what is not. 2 stays at the top, a cubed stays at the top. 3 stays at the bottom, d to the 7th stays at the bottom. So it looks like b to the 5th is going to move to the bottom. B to the negative 5th is going to move to the bottom. C to the negative 4th is going to move to the top. So let's take a look at what that's going to look like. So remember, 2a stays at the top. C to the 4th is going to move to the top. 3 stays at the bottom, and d to the 7th stays at the bottom. B to the 5th is going to move to the bottom. B to the negative 5th is going to move to the bottom and become positive. So this is our final answer. So b to the negative 5th moved to the bottom and became b to the 5th. C to the negative 4th moved to the top and became c to the 4th. Number 12 is somewhat interesting. X cubed is positive, so it stays at the bottom. But I have 5 raised to the negative 2nd. So we're going to have to move that to the bottom. So whenever you do that, you put a 1 at the top. The 5 to the negative 2 becomes 5 squared, x cubed. We want to evaluate 5 squared, which is 25. So we'll have 1 over 25 x cubed. Make sure you don't have any questions. If you do, just rewind the video to hear the explanation again to make sure that you understand. All right, let's go to number 13. Now, does negative 8 move? Good. No, it does not. The actual term being negative has no effect on its exponential factor, okay? But notice here at the bottom we have an x to the negative 3. So we are going to move that to the top with the negative 8. So we'll have negative 8 x cubed, remember it becomes positive because it moved, over 2. Now we're not finished with this because we can simplify negative 8 over 2. So negative 8 divided by 2 is negative 4. So basically our answer is negative 4x cubed. Okay, I hope this is all starting to come together and make sense for you. We have two more problems before we delve into something a little different, just slightly different. We're going to add to what we're doing already. All right, so number 14, let's take a look at this. 6 stays at the top because it doesn't have an exponent at all, and definitely not a negative exponent. Look at a to the 0 power. Remember, a to the 0 power equals what? That's right, 1. But now we have this c to the negative 3. So we see that negative exponent, so we immediately know that c to the negative 3 is going to move to the bottom and become positive. A to the 0 is 1, and 6 times 1 is 6, so the 6 is going to be at the top by itself. Remember, c to the negative 3 moves down to the bottom and becomes positive. Let me rewrite that so I can have room. And then the d to the 5th stays there because the exponent was positive. Okay, remember again, a negative term does not have anything to do with whether it moves or not. It's a negative exponent that determines if the factor is going to stay where it is or move. Okay? So our negative 5 stays as a denominator, and so does our r cubed. But notice we have this s to the negative 1, so we're going to move that to the bottom. Now, since it's to the first power, you really don't have to show that, okay? If you feel better showing it, you can, but you don't have to. So this completes number 15. Okay, well, as I stated, we're going to expand on what we know, and we're going to actually simplify this problem and then substitute. So remember, you should simplify it first. Look for negatives, look for movement, look for simplifying that you can do ahead of time. Then you want to substitute your values and evaluate. So let's take a look. The negative 3 stays where it is. A squared stays where it is because we have a positive exponent, but we have b to the negative 3. So we immediately know that our b is going to move to the bottom and become b cubed. But take a look at what we already have here. Y raised to the 0 power. And remember, anything to the 0 power is what? Correct, 1. So that means when we move the b to the negative 3 down to the bottom, we won't have to worry about having anything down there with it. All right, so let's simplify first. So we have negative 3a squared over b cubed. Remember, y to the 0 was 1, so it's 1 times b cubed, and we don't have to show that because we'll end up with b cubed anyway. All right, so now let's substitute. So we'll have negative 3. A is 4, so let's put 4 squared in parentheses here. B is negative 2. And I tell you what, I'm going to change that top, and I'm going to move Sorry about the brief interruption. Let's move this 2 to the outside of the parentheses. Okay. All right. So now I have negative 3 times 16, because 4 squared is 16, over, we have negative 2 to the third power. So that means negative 2 times negative 2 times negative 2, which will give us a negative 8. And you can put that in your calculator to make sure. So now we'll have negative 48 divided by negative 8. And what does that equal? Good. Gives us 6. All right, let's take a look at this one and let's evaluate. Both x to the negative 2 and y to the negative 1 are negative. So the first thing you want to do is move them. So if the negative is at the bottom, you move it to the top. If the negative is at the top, you move it to the bottom. So to simplify, first we'll have y over x squared. And remember, it's y to the first. You don't have to show that. Okay, so let's do 12 because y is 12 over negative 8 squared. Okay, so what you want to keep in mind here is the negative is squared also. So if you're using your calculators, please make sure to put parentheses around the negative 8 because negative 8 squared is a positive 64. Now, once you get 12 over 64, these are both even. So you know that it can be simplified. Even bigger than that, 4 goes into both 12 and 64. So 4 goes into 12 3 times. 4 goes into 64 16 times. So remember to always reduce your fractions. Simplest form is 3 over 16. All right, and finally we have our word problem. We have a population of insects that triples every year. And we really want to be careful with that because think about that Zika virus that's out now. That is insects transporting that disease. And basically, remember, just like viruses, these things increase exponentially. So that Zika virus is pretty dangerous, and we really want to be careful and protect ourselves. All right, so the number of insects is modeled by the expression 5,400 times 3 raised to the W, where W is the number of weeks after the population was measured. Evaluate the expression for W equals -2, 0, and 1, and what does each value of the expression represent in the situation? Okay, well, I hate to say it, but I don't know what -2 weeks represents. So I don't have an explanation for that one. Now, there are 2 ways you can do it. You can actually use your calculators and input your values for each one. A shortcut to this would be to hit your y equal button on your calculator. After you hit your y equal button, put the expression 5,400 times 3 raised to the x. Then after you put that expression in, hit your second key, and then hit your graph key. And then scroll to find your values. Now, of course, another way to do it is sometimes it's a little neater to actually make a table. And we'll change this to W. So they asked us to evaluate at -2, 0, and 1. So I guess even before weeks have started, if we substitute -2 for W, that's going to give us 600. So even before we started counting, there were 600 of these horrible mosquitoes existing already. When W is 0, that is kind of like our beginning. Remember, anything raised to the 0 power is 1. So we're already starting with 5,400 insects. Kind of gives me the creeps. I don't know about you. Okay, so basically, when W is 0, that means that we've started with 1 week. So in 1 week, we've went from 5,400 to 16,200. And that's kind of scary. But that's how quickly these insects multiply. So that's why it's good. It's really helpful to be good at math, because we need scientists, we need engineers, so that a lot of these viruses and these illnesses and these insects can be destroyed. So that's what we're looking for you to do. Save the world. Bye. You can now start on your homework, okay? And your homework will be due at the end of class.